In this project, we're going to look at what we refer to as bitmap to vector conversion. So ArtCAM Express has a very interesting function in that it allows you to take bitmap images, logos, line drawings, line art, many different things that you could find online, things that you could, images that you could have sent to you, particularly if you're doing work for a customer, for example, that has a logo they would like to have reproduced. In many cases, finding just the right format can be sometimes challenging. The nice thing about ArtCAM is it has the ability to work with many different types of file formats and basically get them into a format that we can use on the machine. So as you can see on my screen, I have Google open. I use Google for most of the searches that when I'm looking for images, I use Google almost all the time because there are certain pieces of information that Google gives me that I find are very, very helpful. So in this case, for example, I've got Google open and I'm just going to search for something. I'm going to type in here Chinese line art, and maybe I'll add another word, another keyword here. I'll put dragon. I usually try to keep the specific. I try to keep the search as specific as I can, so that I give Google a really good idea what I'm looking for. So you can see it's going to give me lots of websites that I can look for information on. But what I want to do is click over here under images. So you can see I've got over 5 million results of Chinese line art, dragon. So I've got lots and lots of choices. So you can see there's lots of images of Chinese dragons here for me to choose from. So there's basically 3 criteria that you're using here to determine whether or not an image is something that you can use in ArtCAM Express. And the key to the success of being able to do this bitmap to vector conversion is understanding this criteria and making sure that you apply that criteria to any search that you're doing. So one of the first criteria that we're looking for is the resolution of the image. So one of the nice things about Google is that as I move my cursor over these images, you see this one here shows me that down on the bottom of it, it's 800 by 451 dpi, or dots per inch. And that's a very good resolution. A general rule of thumb, I don't want anything smaller than 300 by 300 dots per inch. There are a few exceptions to that, but generally speaking, if you stick to that rule of thumb, you're usually pretty good. So you can see this one, for example, is 600 by 847. This one 900 by 500 and change. You can see all of these will meet that criteria as far as the resolution of the image goes. So pretty much everything that I see right now is all good. Here's the second criteria I'm looking for. I want to try to avoid anything that has very, very fine detail. I'm going to click on this one as an example. If you look at how fine this detail is here, that can be somewhat problematic when we're doing this bitmap to vector conversion. And the problem ultimately is that the machine is going to try and machine all that fine detail in. Not only is it going to take an extremely long time to machine, but imagine if your material wasn't completely flat. There may be portions of this that don't machine at all. And while we may put a piece of material through a planer or a sander before we actually put it on the machine, by its nature, wood is never completely flat, and so you may have these little small dips and dives in the material. And so if you're trying to get very, very fine detail, the machine assumes the material thickness to be flat, and if it's not, then you're going to get some areas that are over machined, some areas that are not machined maybe at all. So you have to be very careful with things with fine detail. Now, as you get more experience with your machine, you find ways around that. I've done several projects with very fine detail and basically over machined the project, and then by just using a palm sander, basically sanded down the areas that were slightly over machined till I got the result that I wanted. But early on, it's just best to try to give yourself the best opportunity to succeed with some of the early projects that you do. So with that fine detail in mind, as we look at some of these, this one's not quite so bad. You can see the lines on this a little bit thicker, so this one probably would work out fairly well. Let's go take a look at the next one. Again, very, very fine detail, and not probably the first project I'd like to do, but down the road I'd probably be able to accomplish something with that. And then the third criteria is that I'm trying to avoid anything that has what I would refer to as gradient screens in the image. And the one that immediately comes to my attention is this one. So if you look at this background on this particular project or on this particular image, you can see that it's got these changes in shading, and that's going to be problematic, because what the software is going to do is it's going to trace around this image to try to establish basically where to create machining toolpath. And if you've got all of this changes in shading, that can be a problem, because it can't really determine where to kind of draw the line, if you will. So as we consider those three criteria and you look at the image options that we have, a few of them kind of jump out at you as projects that would probably we could have some success with. If you look at this one, for example, now you may not necessarily love the image, but think in terms of those criteria. You've got high resolution, you've got very, very nice thick lines here, so it's going to machine quite well, and the other thing is that you've also don't have a lot of finite detail. So this particular image would probably do very, very well for us. So let's just select this one. And in order to do so, you notice that I have this option to view image. A very common mistake is that new users will actually save what you see on your screen. And while you see the resolution here, this is not in fact the resolution of this image. This is a low resolution icon that represents the image. What we want to do is click on view image. And when we see the image, it should be the only thing on our screen. So I'm going to click on this, and I'm going to save this image. And I'll just save it to my desktop for now. And we'll just rename this Dragon. And we're going to save that. All right, let's close this now. And let's go back to our Google search. And let's change the criteria. Let's download one more image so we can get another look at some of the variables that we may see as we are looking at these. So I'm going to type in Toronto Blue Jays logo. It would probably partly be because they happen to be my favorite baseball team, but all that aside, there's some interesting iterations of their logo that come up when we do that. So you can see in images now, we've got lots of iterations of the Blue Jays logo. So once again, here's the criteria that we're looking for. High resolution, so this one's 1024 by 1024. This one's 590 by 407. This one is 1200 by 948. So these ones all meet that criteria. The second thing that we're looking for is we want to try to stay away from anything that has really fine detail in it. So as I look through these all look pretty good. You might be having a little trouble with this one here with all that text. That's probably going to be a little bit problematic. But as we scroll through these, you can see we start to get into some that the detail starts to get a little bit fine. This text Blue Jays down here would be a little bit tough because it's pretty tiny. But for the most part, most of these meet that criteria quite well. The third thing is that gradient screen, that change in shading. Let's look at this one right here. This one's a really good example of what you don't want. Even though the logo itself looks pretty good, see the changes in the shading along the outside edge of this. That's going to give us a lot of trouble. So that's one we're going to try to stay away from. In a perfect world, you want something that's black and white. And if you noticed as I scrolled down here, I saw a black and white rendering of the logo. Problem with this one is the resolution's too small, 271 by 204, so it doesn't quite give us what we want. The truth is, the one that probably works the best for us is the first one that shows up in this section here, which is this one right here. It's nice high resolution, very, very clean logo, as you can see. And we're going to go to click view image, and we're going to save this one also to our desktop. And we'll just name this one Blue Jays. And there we go. All right, next what we're going to do is we're going to open up ArtCAM Express. And if you remember in Project 1, we clicked on New Model to create our workspace. This time we're going to be doing something a little bit different. We're going to click on Open Model. And as we go to our desktop, let's start with the dragon image that we first saved. And you'll see that the dragon image is going to pop up on our screen. And you see that it's giving us the option to set the model size. Now, ArtCAM Express recognizes this, and it's seeing the size of that image in dots per inch. But dots per inch is really not a measurable unit for the software. It doesn't understand dots per inch because CAD software, which ArtCAM Express is a CAD-CAM software program, works in absolutes, and dots per inch are not an absolute for it. So what the software wants to do is it's trying to convert this into inches. Now I don't need it to be 720 inches, so I'm going to make this a little bit more workable size. Let's make it, say, 9 inches. That'll work fairly well for the project that I want to do. And I'm going to set the origin position as we've always done in the top left corner. And I'm going to click OK. And you can see now the image size is a little bit more manageable size. I'm going to use a function up here called Bitmap to vector. When I click on that, you can see the window pops up and it gives us a few options. The first thing is it wants to know if we want to reduce the colors. Now, if you look at this image, you would believe that this is probably a two-color image. Looks like it's just black and white. Well, let's actually take a look. We click on Reduce Colors, and you can see that there are 130 different shades of gray. And if I'm just going to close this for a minute, and so you can see exactly what that looks like. As we zoom in on the edge of this, you can see all of the different shades of gray. Each one of those represents a different color. Well, there's 130 of those. What we want to do is reduce that number from 130 to the lowest number that we can without actually losing detail in the image. So click on Reduce Colors and watch this slide bar. As I move this slide bar, I want you to observe two things. I want you to watch the image, and I want you to watch this color palette along the bottom. So as I move this and reduce the number, you can see the number of colors reducing along the bottom. What it's basically doing is it's taking colors and it's combining them. So two colors that would be close together, it's basically combining them to create one single color. As you watch the image, what we're looking for is to make sure that we don't lose a portion of the image. In a perfect world, what we want to have is two colors, like you see here. That can't always be achieved. If you've got, for example, some shades of gray or different colors that perhaps would disappear if you get too low, then sometimes you have to stop at 3 or 4 colors. But in this case, it's worked very well for us, and we have 2 colors. And then the last step is very simply to click on Create Vectors. Now, you'll see that what happened is that it sort of traced lines around the image. I'm going to close this for a second, and I'm going to reduce the contrast on the bitmap in the background, and I want to zoom back in, and I want you to see where there was pixelation. You see that pixelation has been reduced. So you don't have that pixelation. It's created nice smooth machining lines. But where there's a sharp corner, it maintained the sharp corner. So we've got that nice crisp geometry that we're looking for. So let's move over here to Window Fit, and we're going to make sure our project is in the center of our window. So the next thing I'm going to do is I'm just going to very simply go into the middle of my project. I'm going to right click, and I'm going to copy this. So I'm basically copying these vectors that we've just created. I'm going to go up to File, and I'm going to close this model, because essentially this session of ArtCAM Express, the only intention that we had was to actually do the bitmap to vector conversion. Now what we're going to do is we're going to create a new session or a new model, and we're going to set the material size to the size that we want. So in this case, it's 12 by 12. I'm going to use the same size material as we did in Project 2. And I'm going to right click, and I'm going to paste that image into our workspace, and I'm going to center it. And now you can see that we've basically created this image. Now, one of the things you'll notice is that there's a rectangle that's sort of surrounding it, but that's okay. We're going to come back to that in a minute. But basically, we've been able to take that bitmap, convert it to a vector, and as you can see, we've got beautiful machining lines here. This is going to be a great object. This is going to be a great project to machine. And then, as we did in Project 2, the last step for us is to create the toolpath. So I'm going to drag my mouse over the entire object. I'm going to click on Toolpaths, and I'm going to create a V-bit carving toolpath, because again, if you remember from Project 2, we wanted to make sure that we created the square geometry. Our start depth is going to be 0. We are going to limit the maximum tool depth to 0.125 inches. We're going to click to select the tool that we want. In this case, we're going to use a 90-degree V-bit and select. And then lastly, we're going to go down here, we're going to check those two things. One of them is we want to make sure our safe and our home Z is set at 0.2 inches. And we want to click to define the material, and we want to set our material thickness. In this case, we're going to assume a 3/4 inch material thickness. Material Z0 and model position of the material, set it at the top, and we're going to click OK. And we're going to calculate that, and you'll see that it creates the toolpath here for us. And we're going to close this window. Now, one of the things you'll notice is that when you create the toolpath, it sort of fills in all of this area with toolpath. This can be turned on and off by very simply clicking this little light bulb here to the right of toolpaths. So I don't have to see those. And sometimes if I'm editing, it's just easier for me to have that turned off. But then lastly, we're going to click on simulation, and let's just actually simulate this project and see what it's going to look like. And you can see that it's clearing out all that area that we wanted to have cleared out around the image. Now I've got my resolution for my 3D preview set at the highest setting, so it can sometimes take a few seconds for it to refresh or to actually create the toolpath simulation. But you can see that it's coming along quite nicely, and when it's finished, there's our image. Now let's just zoom in and let's rotate this on its side, and you can see that we've created that dragon and we've machined the area all around it. Now I want to go back to the 2D view for just a second, and I want to introduce another little element to this project. Let's suppose that we looked at this project and decided, as we looked at the 3D view, that we weren't happy with what we had here. Perhaps we would like to have this whole process reversed. In other words, we'd like to have this this area maybe not machined and maybe have the dragon cut out. There's an easy way to do that in using the VBit carving toolpath. So just to explain, when I create a VBit carving toolpath, basically what happens is that the software works from the outside in. So it sees the first line that it sees, in other words, the first vector. It machines in between this vector and the next vector that it sees. So it's going to clear this area out. Then it's not going to machine this at all. It's going to leave that alone. It's not going to machine this. It's going to leave this alone. But it would machine in this section in here. It's going to machine in here. So it's going to kind of skip every other section, so it creates those various levels of depth. If I wanted to reverse that process, it's a very simple way to do that. I'm going to click on Create Rectangle, and I'm going to select Rectangle and not Square, and I'm going to just basically draw a rectangle around the existing image that we have. And I'm going to center that rectangle. And I mentioned in Project 2, if I want to recalculate a toolpath, I just click this plus sign to the left of toolpaths, double click on the toolpath that I've already created, and in this case you can see it showing the vectors that are selected for this particular toolpath. In this case, I'm going to drag my mouse over all of it and basically recalculate this toolpath to include our new vector. And you can see that it did that. And then we're going to click Simulation, Reset Simulation, and simulate all the toolpaths. And you can see that it's going to be a very different look this time. Now it's machined the dragon out and left this area around it. Now, needless to say, this is going to take a lot less time to machine than the first project, but it may not be what we're looking for. But in a very few seconds, I can basically add that extra vector and determine if this project is one I'd rather machine this way or the way that you saw originally. And then finally, once again, clicking on Toolpaths in the project pane, I'm going to click on Save Toolpath. And as we did in Project 2, we see that we now only have one toolpath, which is that carving toolpath. We're going to save it to my download section. We're going to call this one Test 2. And we're using the GTEC machine file format, GTEC being the manufacturer of the machine. And we're going to save that, and now we've saved that NC file to our, in my case, to downloads, but we could have saved that to the flash drive and send it directly to the machine for final machining. All right, let's close this model, and we're going to not save this change. I'm going back to the start screen again, and we're going to run through this a second time using the second logo that the second image that we saved, which was this Blue Jays logo. So we're going to open this, and once again, you will see that it's going to give us an option to change the size of this image. So I'm going to change this into a little bit more workable size. We'll make it 10 inches. And we're going to do the same thing again, bitmap to vector conversion. And now the reason I wanted to do this a second time is because now we're working with a color image. So if I click on Reduce Colors, you can see now we have a lot more colors. There's 251 this time. As I begin to reduce the colors, though, one thing I'm looking for, particularly concerned about the red. if that red was light enough, there may come to a point, if I get down around 3 colors, if I dropped it to 2, that red may disappear, that maple leaf, because it might be too light. In this case, I'm okay, and that's what I was hoping for. But if that were not the case, then I may have to stop at 3 colors and then be able to do the bitmap to vector from there. But in this case, it all worked out well for us. We were able to do it with 2 colors. We're going to click Create Vectors. Again, we're going to reduce the contrast on our bitmap, and you can see that we've got very nice machining lines. This is going to turn out really well for us. And once again, we're going to right click and we're going to copy this, and we're going to close this session down. Don't need to save the changes because all we wanted to do was the bitmap to vector conversion. You're welcome to save them if you like, but there is no need to, because very simply you're going to open up a new model. Again, I'm using the same material size at 12 by 12. Just going to right click and paste our vectors in. We're going to center it. You'll notice it put it up on the top. It's very simply because I didn't select the bottom or the top left corner as our start point when we did the bitmap to vector conversion. And now one of the things I have the option to do, you notice I've got this border around it, but in this case this border is not in any way connected to the logo. If I don't want the border, I can now delete it. Perhaps I don't want that trademark logo. I can also delete that as well. So now I'm left with just the image. I'm going to drag my mouse over the whole thing, go to toolpaths, and we're going to select again that VBit carving toolpath. I won't change any of the parameters of this. We'll just use what we've been using all along. We're going to set our maximum depth at 0.125 inches. We're going to select the 90-degree VBit, and we need to set our material thickness, or define the material. As you can see here, we're going to define the material at 0.75 inches. Click OK and calculate. And finally, let's do a quick simulation and make sure that we're happy with this logo. And just so you know, if you change the resolution on your simulation, it does not in any way affect the performance of the machine. And we'll just rotate this and have a look. Now, I want you to notice, as you look inside of these machined areas, you can see machining lines. Now, you notice that we used a 90-degree VBit as the only tool that we selected. And so what is basically happening here is that 90-degree VBit is clearing all this area out. It's going to take a little bit longer, but it also could potentially leave us some machining lines because we're using the tip of that 90-degree VBit to clear that area out. If we weren't satisfied with that, or if we wanted to decrease the machining time, I can very simply, over to my toolpaths, open up the VBit carving toolpath again, and you'll see in that VBit carving toolpath there is an option to add a roughing tool. So if I wanted to, I could go down to my tool section here. I'm going to pick an 1/8 inch end mill. So I'll use an up spiral end mill, which is the up spiral end mills are typically used for clearing. Down spiral end mills if I was cutting a part out, because you want to keep a nice finished edge. I'm just going to recalculate the toolpath, not going to change anything else other than that. And then I'm going to resimulate this, and you will see the difference. So there's the roughing toolpath. Here's the finishing toolpath. And you'll see this time, as we look at the machined area on the bottom of the leaf, you can see that it's nice and clean because it's machined using the 1/8 inch ball nose to clear out this area first. There will be some areas where the 1/8 inch ball nose will not be able to fit, and you may see some little bit of machining lines in these corners, very simply because the 1/8 inch ball nose or the 1/8 inch end mill can't fit in there, so it has to use the VBit to clear it out. So there's 2 examples of bitmap to vector conversion, and of course in this case the last thing for us to do once again is to save the toolpath. Again, using the appropriate post-processor or machine file format, and again you see we have 2 toolpaths listed here. So this is a case where we'd be running a 2-tool operation, and we do have a video that shows the tool change function on the iconic machine. So you will be able to use first your 1/8 inch end mill to do the roughing, change tools, a 90-degree VBit to do the finishing, and you can complete this project much quicker and get a nice finished surface on the bottom of those machined areas by using the end mill. And the last thing is we'll change this name to test 3. and save that toolpath. And that's the end of this video. So that is bitmap to vector conversion. The last video in this basic training series is going to cover off importing and creating a machining toolpath with a 3D model.